Today class, I will give the brief idea about what is big data and what is Hadoop ecosystem and what is NoSQL. And recently, we are in market. We are hearing these names: big data and Hadoop ecosystem and NoSQL. And also, I will give the details about the trainings. What I will, how I will approach in training. What are the materials and what are the things I will give in. I will discuss about that one also end of the session. Okay. Anyone have any idea about the big data? What is big data? I think you're thinking big data is a database or tool. Any ideas?
No.
Okay. Any one of you? Okay, fine. I will tell. Actually, big data is not a database. It is not a tool. Big data is a concept to tell about the problems when we are having the large amount of data. Means big amount of data. How we can store the large amount of data. How we can process the data. So it will tell about the these problems about big data. Next slides I will tell clearly. So before going to this big data, so recently from past 2 years we are hearing about these terms big data and Hadoop, NoSQL. Why we are uh, getting popular about these things. If you observe few years back, I think 3 or 4 years back, so less people only are using the social media and the this thing and online shopping and everything, online transactions and mobiles and everything. So that time we are not getting this large amount of data. So coming to, if you observe past 2-3 years, so a lot of people are using the social media and online shopping and this mobile usage and chattings and mails and etc. And so a lot of people are using the internet applications and the mobile applications, and we are getting we are generating the large amount of data. So because of all these sources, we are getting the large amount of data. So data means previously coming to 4-5 years back. 4-5 years back, we are handling only GBs of data, but now we are getting large amount of data, terabytes, petabytes, even more than that one. We are getting. So what are the sizes we are getting? I will tell in the next slides. So these are the okay. So in this screen, so if you look into this screen, so we are getting the data from the lot of sources from the internet. So how much data we are getting? Currently, I think from internet we are getting 1.3 zettabytes. Zettabytes means I think 10 power 21. Next slides I will tell you what are the data sizes we will have and what how much terabytes and petabytes, more than that 1 zettabytes. So this much amount of data we are getting. So these zettabytes of data and and also we are getting daily, we are getting the lot of data from these social media and YouTube and Facebook, Twitter, LinkedIn. So from these we are getting the lot of data. So we can handle these data by using the normal RDMS. So how we can store and how we can process the data. All these things will come in the big data concept. So this is the example of how much we are getting the data in current present. We are how much data we are getting. These are the terms. And next, coming to this is the sample data from the daily, how much the sample data about the how much we are getting from Twitter data. This is amount of data we'll get from the Twitter. This is the one example from Twitter. And also other sources of big data we are getting from aircraft, and we are getting the some ERP systems, and also we are getting from the this other mobile devices, and these sources also we are getting some we are getting the large amount of data. So these are the data sizes. I think previously we are seeing, I think maybe we are handling about the AWS, we will handle up to about the gigabytes only. But presently we are getting terabytes, petabytes, exabytes, and zettabytes also we reach. Zettabytes means 10 power 21. So, and etabytes and brontobytes also there. So these much of data we can handle through normal RDMS or previous existing database systems. So how we can store and how we can process, these are the question mark in the big data. So these are the things how we are getting this amount of data. So big data means we are getting the from the lot of internet sources and social media, and how much data we are getting. This is the idea about the rough sizes about the this how much data we are getting. So if we are talking about the big data, we need to discuss about these terms: volume, velocity, and variety. Coming to volume, so big data will tell about the problems about these three things. So next we will discuss about how we can what are the solutions for these things. We will discuss I will tell you in next slides. So coming to volume, so from past 2-3 years we are getting the data very fastly. So we are getting the data petabytes and more than that data. So how we can store the database without failures, and how we can store this large amount of data, it will tell under the volume. Next, coming to velocity. Velocity means how we can process the this large amount of data fastly, and also I think we have the some streaming data. We will get the some streaming data from the some application like Twitter, and some other application will get the streaming data means continuous data. So how we can process this continuous data very fastly? These things will come under the velocity. Next, coming to veracity, variety. Variety means generally in RDMS or existing databases, we will store only few kinds of structure kind of data or flat files kind of thing, kind of data only we will store in the RDMS or traditional databases. So, but how now we are getting the different kinds of data. So we are getting images and audios from the Facebook or Twitter, and also we are getting the weblogs and clicks and sensor data and RFID, and we are getting different kinds of data. Means we are not having the data in the single format, text format. We are getting the data in Word files, Excel files, PDF files, and JSON, XML, HTML files, and different kinds of varieties of data we have. Here we have the structured, what are the different kinds of database: structured, semi-structured, and unstructured data. So structured means everything will be in, it will be in some format, comma separated data, space separated data. It will have in some same format. similar format like our RDMS tables. RDMS tables is example of a structured, and semi-structured, for example, semi-structured data may be HTML, XML files are the semi-structured. And also coming to unstructured means this image, videos, all will come under the unstructured data. So these are the, in big data, these are the problems, how we can store the large amount of data, how we can process the large amount of data, and different kinds of different variety, different kinds of data, how we can store under the single platform. So all these things will come under the big data. So for solving or for solving these problems, we will have the we will have the different technologies. In that we have the one main technology or framework is Hadoop. So next slide I will discuss about the Hadoop, what is Hadoop, and how we can proceed with the Hadoop. I will give brief idea about what is Hadoop. So this is the introduction about the why we are getting why we have the big impact on the this big data in the market, and why it is getting popular in the market, this big data term. This is the introduction about the big data, and what are the terms in the big data. These are the terms: volume, velocity, and variety. So what are the fields? Next, what are the fields we are using this big data? So initially this big data will started in few things. So initially we actually getting popular with the social media website, analyzing the this log analysis and the finding the fraud detection kind of things. It is getting familiar. Now it is in all different fields. It is getting popular in IT infrastructure, local discovery, social network analysis, and also traffic flow optimization. In traffic, I think we'll get a lot of data for analyzing the traffic kind of thing, and also natural resource exploration and weather forecasting and fraud detection. So all these fields, big data is getting popular. So next, coming to why Hadoop is popular. So these are the, till now we discussed about the these things, how we are getting the big data, and what are the terms in the big, this big data. So what are the challenges in the big data processing? So till now, I think before Hadoop and before this big data technologies and this thing, I think a lot of people are using only this RDMS or RDMS databases. So in that we don't have the that RDMS databases are not able to handle the large amount of data, and you don't have the scalability capabilities and parallel programming, and you don't have the all these capabilities. So what are the specialties in the Hadoop, and what are the features in the Hadoop? I will tell you. So coming to first thing, so we need to store the large amount of data. So for storing the large amount of data, we don't need to having the we don't need to provide the high-end servers. Means we don't need to purchase the more cost with the from the Oracle data centers or something. So we just need the commodity hardware. Commodity hardware means cheap hardware. Just we need to provide the one machine, and we need to provide the more RAM and the disk and CPU. CPU means cores, dual core, hexa core. Those things only we need to provide for storing the data. So that is the commodity hardware. So no need to provide the high-end servers. So we need to provide the low-end servers. Low-end servers means no need to having the high capabilities. We need to just maintain the we need to provide the RAM and the hard disk for the storage and the CPU. So next thing it means, if you provide the less than hours, there is a chance of the failure of the machines. How we can handle? By using the, we have the one concept called fault tolerance. Fault tolerance means, so if any suppose if I store the data in the 5 machines, so if any machine is failed means we won't lose the data. So how we can achieve, I can tell in next slides. So basically main thing in Hadoop means we will achieve by using the replication. So I will tell more details about the next slides. So we can achieve the data nodes failure by using the fault tolerance concept. So coming to one more thing is why most of the companies are interested to bring the Hadoop technologies or big data technologies. Main thing is big data and big data tools are Hadoop. Is the everything is open source. No need to pay money for the this Hadoop tools or Hadoop technologies. So everything is open source. So most of the, so if you install in the Linux, so we no need to pay anything. Just to, whatever the latest software is, latest version is there, we can directly install into the n number of machines and we can use it. That is the one of the main feature in the business point of view, company's business point of view. Next, coming to how we can store this amount of data. So basically we in this Hadoop we have the concept called distributed storage. So instead of storing into one machine, we will store into data into distributed fashion. How it will store and how the data will store into different distributed machines, I will discuss in next slides. So before going to that, here we have the two terms, scale up and scale out. Scale up is nothing but a vertical scalability. Previously in RDMS cases, we will do scale up. Scale up means increasing the capacity of the single machine. So that means increasing the capabilities of the RAM and the this one hard disk sizes we can increase. So but up to some extent only, up to some limit only, we can increase in the vertical scalability or scale up. So after that limit, we can't increase the RAM or we can't increase the this hard disk. So what is the alternative? Alternative is horizontal scalability or scale out. Horizontal scalability means instead of increasing the single machine capabilities, increasing the missions. So if we are suppose now if we are having the 2 missions, further we are getting the more data, we can add the 2 more missions or 3 more missions. How we can add these missions, how we can add the missions to the cluster, I will tell in the while explain in the Hadoop. So this is the horizontal scalability. And so in Hadoop, if we store any, suppose if you are having the 1 GB of file, if you are trying to store in the this Hadoop, so it won't store in this single machine. It will be cut into different pieces and it will store into the it will be stored into different machines in a distributed manner. So that pieces we will call it as a blocks in the Hadoop. So what are the blocks, how it will be stored, who will distribute to different machines, I will tell in the next slides or next classes. So this is the idea about what is horizontal scalability and what is distributed mean. Next, coming to one more feature is parallel programming or parallel computing. So in this one, suppose if you have the 1 GB, suppose if you want to process 1 GB of data, means counting the number of lines in the 1 GB data, or counting the how many times word is repeated, kind of things. If you want to process anything, instead of doing one mission, multiple missions will involve in the same data. So suppose now I have the 1 GB of data. 1 GB of data is distributed to different machines. So whatever the machines having this data will process parallelly. So because of this one, load will be very efficiency will improve, and load also will be less. Load will be all the nodes will have the less load. So suppose if 1 GB file is, if one machine is processing the 1 GB file, all load will be on the single machine. So instead of that one, multiple machines are processing the same 1 GB file, less load will be there, efficiency will be there. So how we can achieve this parallel programming? Next next slides I will give idea about this one. So these are the main capabilities why Hadoop becoming popular, and also big data processing challenges. So we need to maintain the commodity hardware, and we need to fault tolerance, means we need to avoid the data loss by using the replication concept. And also Hadoop technology is open source. And one more thing is, it will provide the horizontal scalability and distributed storage, and that is the horizontal scalability or distributed storage under the storage part. And coming to processing part, it will be parallel computing or parallel processing. Coming to processing side, so these are the main features about the this Hadoop. So next, coming to
is my voice audible?
Yes, Sekhar, tell me. Yes, security point of view, I think initially, initial days we have the lot of security problems. Now they are introduced lot of tools for the security, and also for database. I think mostly we will store the different users will store the this data. So we can provide the only read permissions, write permission, execution permission kind of things we can provide. And recently lot of tools are coming came for the this security point of view.
Hey Srinivas, I have one question at this point.
Tell me.
Hey, from your explanation, I understood that Hadoop is a server, right?
Hadoop is not a server. I will tell next slides. I will tell full details about the.
Is it a software that handles extracting information from unstructured data source and structured data sources and all, and it gets it extracts the information from there and loads into some, whatever you said, some server that we are going to configure?
Yes. But I will tell next slides. I will tell what is more details about the Hadoop. And Hadoop is not a it is a open source framework. Next slides I will tell you.
Fine. Thank you.
Till now, what are the capabilities Hadoop having? What are the features, or what are capabilities having Hadoop? That things only I discuss. So next slides I will give the what are the tools. We have the different tools under the Hadoop. I will tell one by one. I will give more details about your question.
Yeah, the reason for asking is actually we need two kinds of software. One is to load, to extract the information and to load into servers, and to manage the data in the server, right? So
yes. I will give more idea about the Hadoop. So next slides. Then you will get more.
Sure. Thank you.
Okay, and next, coming to Hadoop history. So initially 2002-2003 time, one project is started, Nudge project. That is a such kind of project. Then 2003 and 2004, Google introduced the GFS. GFS means Google File System, and the also storage side they introduced the GFS, Google File System, and processing side they introduced the MapReduce. So they just published the only papers. They didn't tell about the internal details about the technology. They just publish about the GFS and MapReduce. So these things only they provided. Based on that one only, later Hadoop is created. Hadoop, we have the main two basic components are the two components. One is the HDFS, that is created based on the GFS, and one more component for processing is MapReduce. Next slides I will give the more details about the HDFS and MapReduce. Duff cutting is the creator of this Hadoop. So actually, how we got this name Hadoop means Hadoop is a child's toy name. Actually, this name is came from the Hadoop is son toy name. So from because of his son toy name, we got the name of the Hadoop. So Hadoop, why this name means it can handle the basically it is the one kind of elephant name. So it can handle the large amount of data it can process. So that's why only this name Hadoop it came. So Hadoop is introduced in 2006. Later it will be take care by the different different companies like Facebook and Cloudera and some companies. So and they introduced this some tools, and they merged into Apache Hadoop Apache license. So this is the introduction of how it came the Hadoop name, and later how it will be went to Facebook and Cloudera. And 2009 it will be 2008 it will be merged into the it will be Cloudera is introduced, and I will tell more details about the Cloudera and other distributions also came. Cloudera and Atomworks I will tell later. So from past 2011 or 2012 we are lot of people are started learning, and now it will be become popular in the market. This is the history about the brief history about the Hadoop. Coming to next, what is the Hadoop? Hadoop is a open source software for storing and processing the large volume of data or large data sets. So it will provide the environment like a for storing the large amount of data and processing. So how we can store the this data in the how we can store, how we can process, I will tell in next slides. So basically Hadoop is a open source software framework. So we will have the different basic components in the under Hadoop, HDFS, MapReduce, we will have the different component. So for storaging we will have the one component, for processing we will have the one component, and we will have the few more components. I will tell in the next slides what are the components. So what is Hadoop means? Open source software framework for storing and processing the large amount of data. And Hadoop is a fault tolerance distributed. Hadoop will provide the fault tolerance distributed file system for storage and parallel computing for the processing. So and we don't need to maintain the expensive systems. We can run in our machine, our single laptop also we can run, and also we can if you want to maintain some cluster, we can run it on the commodity hardware. So it can be run on different machines. So most of the current in production systems, most of the production systems will have the installed in the Linux. So Windows we need to take the license. So for Linux, most of the Linux versions we no need to we no need to maintain the we no need to have the license cost. So that's why only most of the in production Hadoop production is installed in most of the machines in Linux. So coming to fault tolerance, so if any data node or if any machine is failed, we no need to bother about the data loss. It will be take care about the Hadoop framework. I will tell how it will be take care on in next slides. High reliable and efficient storage system. And main features of Hadoop are distributed storage, fault tolerance, horizontal scalability, open source, community hardware, and parallel processing. These are the things I explained previous slides. These are the main features of the Hadoop, and fit for the lot of application. So initially most of the Hadoop applications is started with the web log processing and page indexing and page ranking and complex event processing and some more applications also there. So for the this add recommendation. So if you go to any product websites, left side, right side, we'll get the some recommendations. So if you are going to buy one any product, we will get the some recommendation. How we'll get these recommendations? By analyzing the their products data. And also if you go to some social media sites, Facebook or this LinkedIn data, right side, if you are visiting some a profile in the LinkedIn, right side we'll get this some similar kind of profiles, recommendation, similar kinds of friends will show. How we'll get means by analyzing the large amount of data. So these are the some sample applications about the Hadoop. Coming to Hadoop, so in Hadoop, I think previously Sekhar asked some question. Hadoop will have the storage and processing. Storage will be under the for storage we have the one component called HDFS. HDFS means Hadoop Distributed File System. So in this we will if you store any data, suppose if you are having the suppose 10 GB of data. So if you store that 10 GB of data, it won't be stored into single machine. Suppose if you are having the 5 machines, it will be distributed to the 5 machines. So in that fashion, so we can store the large amount of data. So one machine can store the large amount of data. So that's why only they are providing the distributed storage. Suppose now we are getting the GBs of data. Further, we are getting the terabytes of data. In that cases, we can increase the more machines. How we can increase? I will next classes I will tell if you and next Hadoop components and how more details I will tell in the next class how we can store and how Hadoop framework will take care about this distributed storage. Mainly in HDFS, if you store any data, it will be split into blocks. It will be split into small pieces. That pieces we in Hadoop terminology will call it as a blocks. So block will have the some default size 64 MB by default. I will tell in the next slides. So main this HDFS what will do means if you store any file, it will be split into blocks, and some blocks will be stored into some machine, some blocks will be stored in some machine. Like that, the data will be distributed. How? Suppose if you want to process or if you want to run any programming on that data, how we need to know the which data is there in which machine. That will be take care about the Hadoop framework. I will tell in the next classes. So this is the main what is the component and in Hadoop from storage side is HDFS, Hadoop Distributed File System. So whatever you stored in the Hadoop means it will be stored into the HDFS. So we need to store into HDFS. Suppose if you want to analyze any data, first we need to store into HDFS. So for storing into HDFS, we will have the some HDFS commands. So and also we need to interact with some programming languages. Whatever the prerequisite knowledge we needed, I will tell in the next slides. So this is the basic idea about the HDFS. HDFS we will use for the storage. In storage, we will provide the distributed manner. That is the just basic introduction about the HDFS. Next, coming to the mapped disk. So now we store the data in the distributed fashion. If we want to store data, if we want to process parallelly, we have the one component called mapped disk. What we will do in mapped disk, I will tell in next slide. So this is the mapped disk means we will use for the parallel processing. Parallel processing means instead of one mission, if you given any job or any task, so instead of processing one mission, multiple missions involved in the processing the data. So that thing we'll call it as a parallel processing. So this is the from storage side HDFS and mapped disk side storage side HDFS and processing inside the MapReduce. That is the basic introduction about the HDFS and MapReduce. Coming to this, Hadoop will follow the master-slave architecture. In master, if you want to interact with anything, we will interact with the master only. So we won't interact with the slaves. So if you want to store any data, first we will go for the master. Master will give the details about the slaves, and then it will Hadoop framework will store the data into different missions. So this structure will follow the Hadoop master and slave. So I will give more details about the what are the components it will be in master, what are the things will happen in the slaves. I will give. But now what you need to know, what you need to understand is, so in master we will have the only information about the yes reader. Slaves is nothing but a different missions. Master is also mission, slave is also mission. So master will have the name node and slaves will have the data nodes. I will tell more details about what is name node and what is data node. But in master we will have the information about the how the data. If you are going to store some data, or suppose 10 GB of data, so in which missions this data is storing, and what are the blocks is storing into slave 1, what are the blocks are storing into slave 2. This information it will master will having that information. Slaves will have the actual data. So splitted data will have the slaves will contain. Slave is nothing but a missions, different missions. So yes, reader. So master will know about the which data, which these I'm telling the data will split it into blocks now. So which block is stored into which mission, or which here we will call it as slaves. So which is slave, master will having all that information. So how this information will have and next slides I will tell clearly how the data is split into blocks and how the blocks is stored into these things. So I will tell in the next slide. But now understanding is Hadoop will have the master and slave architecture. So master will have the information about the this data blocks, and slaves will have the actual data. This is the thing. So master will have the different services processes. These are called name node, secondary name node, and job tracker. And slave will have the data node and task tracker. I will give the next class. I will tell about all these services, all the information. So this is the Hadoop architecture. So in master we will have the name node, and slaves will have the data. So data nodes will have the actual data. So name node will have the metadata about these blocks. It will have. This is the brief idea about the architecture, how it will be there. These racks also I will tell later. I will give clear idea about what are the racks. So next, coming to 1 minute. I will give the basic idea about the how the how the data will be split into blocks, and how we can avoid the data loss, and how we can provide the fault tolerance feature in HDFS. So coming to here, we have the one file. Suppose that file is split into 4 blocks. So how the data will be split into blocks? It will be based on the block size. So by default, the block size is 64 MB. If we want, we can increase the multiples of 64 MB. We can decrease, we can give below of the 64 MB. That is the default size in the HDFS. So if you have the 1 GB file, it will be split into 16 blocks. So each block size is 64 MB. So these blocks will be split. Some blocks will be stored into one machine, some blocks will be stored into other machine. So like this, data will be distributed into different machines. So here we are showing block 1 is there in different machines. So why means because of replication factor. Replication factor is nothing but a maintaining the multiple copies. Because of maintaining the multiple copies, we can suppose here if you one data node is lost means we can go for the other data nodes for the this one for the avoiding the data loads or fault tolerance feature. So here one more question is we are maintaining the multiple replication means multiple copies. Here because of multiple copies we won't get any duplicates of data. Why means at a time we will use only one copy of data. So which copy we need to use, that will take care by the this one that will be take care by the this Hadoop framework. Same block of 1 minute. I got a one question. I will. Yes, if you want to store the 2 GB of data, if we are having the replication factor, we need to provide the 2 GB into 6 GB of data, minimum 6 GB of storage we need to provide. Why means replication factor is 3. Suppose if you are going to store the 2 GB, so we need to maintain the 2 copies, means we need to provide the 6 GB of server capacity we need to maintain. And same block of data will be stored into different slaves. Is it called fault? Yes. Fault tolerance means fault tolerance is nothing but avoiding the data loss. How we can avoid the data loss? By using the replication factor. So replication factor is nothing but maintaining the multiple copies. Fault tolerance means that is the avoiding, how we can avoid the data loss. Suppose if one machine is down, one data node is down, how we can avoid the data loss. That concept is called the fault tolerance. You got it, Naren? Okay, thank you. Okay, this is how we can maintain. Here one more question is for suppose for 2 GB of data we are providing the 6 GB, but we are using more space. But here we are maintaining only commodity hardware, so that's why we no need to bother about this hard disk or server capacity. Why means we are not maintaining the high-end server. We are maintaining only commodity hardware. We are just providing the RAM and hard disk. So in this point of view, in business point of view, main thing is in any point of failure, we no need to lost the data. Suppose in Google, if you take the Google or Facebook, any Amazon or any websites, so main thing is we don't need the we need to avoid the data loss when the data, any single machine or fail, or any data entire data warehouse is in single data warehouse failed, we no need to lose the data. That is the main thing. That's why only here main concept of the this replication factor. So I will tell more details about the how more clear picture about these blocks and the replication factor later. So this is the main introduction about the how the data it will be stored into HDFS. Without the replication factor also we can store the data, but it will be stored into one machine. So if one data node is failed means data will be lost. Suppose I think if you want initial if you want to started with the this Hadoop data, we will store into single machine only. In that cases, we will maintain the replication factor as a one. So coming to production or coming to real time, we will maintain the replication factor as a 3. So we can run the Hadoop with the replication factor 1 also. But if one data node is fail means data will be lost. If you now if you want only one copy of that original data, you can give as a replication factor as 2. But in production, the default replication factor is 3. Replication factor is 3. That is the introduction about the HDFS. I will tell more details about the what is the name node, data node, and I will tell the more details in the next classes. Coming to MapReduce, what we'll do means Now we store the data into different machines. In mapper stage, what we'll do means we will in mapper stage we will process the local each machine data, and we will club into um, in reducer phase we will get the all these mapper output, and we will perform some aggregation operations, means like sum, count, and finding the minimum and average, maximum kind of things we will do in reducer. So what main thing is, in mapper side what we'll do means, in each whatever the data in local machine will process data parallelly, and those output of the mapper will combine in the reducer. Reducer what kind of operation will perform means, basically will perform as a count, sum, or minimum, maximum, aggregation operation will perform into reducer. So this is the idea about the MapReduce. MapReduce what we'll do means, in HDFS side we will store the data into distributed fashion. So each machine will have the some data. So if you want to run some program on the data, so data is in different machines. So mapper what will do means, it will first it will what are the operations we want to perform. Suppose if you want to count the words, we will write the logic in the mappers. So that logic will execute it parallelly. Instead of running logic in the single machine, same logic will execute parallelly in different machines. So that output of the mapper will combine by the reducer. So reducer will merge the will combine all the output of the mapper and will give the results. So this is the basic idea about the what is mapper and reducer. I will tell the more details in the next classes, what is mapper and what is reducer. So for this map reducer, we need to have the Java knowledge. I will tell next slides. I will tell what are the prerequisite tools or technologies we need for the this Hadoop, learning the Hadoop. I will tell next class. This is the basic introduction about the MapReduce. SS MapReduce is the programming language. Correct, Sekha. How we can set the replication factor, I will tell in the next classes. While discussing more details about the Hadoop, I will tell in next classes. So HDFS is the storage. MapReduce is the programming language. We need to use the basic thing is Java, and full Hadoop is developed in the Java programming. So if you want to write MapReduce, we need to write in the Java. But if you don't have Java knowledge, if you want to write the MapReduce program, if you are having the knowledge about other programming like Python, Perl, or C, we can write into that language also. We can write. So next slides I will give more details about the what are the programming knowledge we need. I will tell in the next classes. So this is the basic components about the HDFS and the MapReduce. What are these? What will do in the HDFS and what will do in the MapReduce? This is basic idea about the HDFS and MapReduce. Coming to basically those are the basic components. Based on these two components, we have the lot of other tools in the Hadoop ecosystem. Basically, all the Hadoop tools we will call it as a Hadoop ecosystem. In Hadoop ecosystem, we have the different tools. These are the basic tools in the Hadoop ecosystem tools. Other than this, we have the lot of other tools, but these are the basic tools in the. We need to, if you want to start it with the Hadoop, we need to learn about these tools. So in training period also, I will give the training on the all these tools. So basic thing is HDFS. If you want to store any data, we need to store into HDFS. Then we need to process anything. We need to write the MapReduce. For writing the MapReduce, we need to having the knowledge of any of the programming knowledge. If you don't have the programming knowledge, we can manage with these tools. I will tell in next class, Naren, what are the programming languages we needed. I will tell in the next slide. I will give more details. Okay. For MapReduce, we need to having any programming, programming knowledge. if you don't have the programming knowledge, so suppose if you previously were working on ETL tool, or if you are working on the data warehousing technologies, we can we can analyze the data with the Hive or Pig, Hive or Pig. Hive, basically Hive will provide the SQL kind of language. We can analyze the data by using the SQL queries. So, but it is not a database, it is a data warehousing kind of tool. Hive is a data warehousing kind of tool. I will give more details in the next classes what is Hive, but basic thing is, for learning the Hive we don't need knowledge about the Java language, but in some point of view we need the Java. Means if you want to, what are the existing things, for using those things we don't need the Java. If you want to customize anything, we need to have the little bit Java knowledge. What extent we need the Java knowledge also I will tell in the next slide. So this is the idea about the Hive, and also we have the one more tool called, for analyzing data, we have the Pig. So Pig is a kind of scripting language. We need to write some different kinds of different statements in the Pig for loading the data and for filtering the data, for grouping the data. We will have the different commands in the Pig. So we need to write, we need to execute those things. So for Pig also we don't need the Java knowledge, but in further if we want to do any customizing kind of thing, that point of only we need to Java. Means why we need the Java means everything, all the tools they developed in the Java. If you want to customize anything, suppose coming to Hive, we will have the some user defined functions for the sum count kind of thing, uppercase, lowercase. More than that, if you want to customize anything, that cases only we need the having the knowledge about the Java. So otherwise we don't need Java in the this Hive or Pig tools. One more tool called Scoop. Scoop is for suppose if you are having data in the RDMS, if you want to transfer to the HDFS, or if you want to transfer data from HDFS to RDMS, Oracle or MySQL databases, we will use the Scoop tool. I will give you more details about next class. This is the basic idea about the Scoop. Is for the transferring data from RDMS to HDFS or HDFS to this RDMS. Next we will have the Apache HBase. What is HBase I will tell next classes. Sorry, next slides and next classes. So next slide we have the one concept called NoSQL. While discussing that one, I will tell about this HBase. And we have the one more tool called Flume, Apache Flume, for passing the, for getting the streaming data. We will use this Apache Flume. And if you want to schedule these MapReduce jobs or Hive queries or Pig commands, Pig jobs, we need to use the one scheduler framework called Apache Uji. So by using this framework, we will use this Uji framework for scheduling. So these are the basic. These are the if we want to start with the Hadoop, we need to learn with these tools. So in training period, I will give the all the details about these tools, and I will give the practical environment to practice, and I will explain the I will give some examples for practicing these tools. Next, coming to what are the Hadoop use cases. Main, why we will use the Hadoop. We will use for the analyzing the data. One example is weblog analysis. Suppose we are having the websites. So we are having the website, different product websites, Flipkart or Amazon websites. So if we want to analyze something from this data, what we will analyze? If we want to analyze how much, how many users are hitting the websites for every hour or every day, and what are the which page most of the visitors are visiting, and that kind of details, how we can analyze. So these websites will generate the large amount of logs. So backend, these websites will have a lot of will have the different web servers. So from web servers we will get the large amount of data, logs data. So if you want to store that logs data, will have the petabytes or terabytes of data. So how we can store this amount of data? We can store this log terabytes and petabytes of data into Hadoop. So we need to go for the HDFS. And these data, what we will do with this data, we will analyze this data, and we will provide the some charts or the reports for the analyzed data. So what kind of data will show means how many hits are there, how many pages are most of the visitors liking which page. That kind of analysis we will do, what product they are liking, that kind of things. And also we can analyze country wise, which country, from country wise it's under which, from which area or which country we are getting them more visits for our website. That kinds of data, that kinds of analysis we can do with the Hadoop. So this kind of analysis we can do with the normal RDMS thing. So what we'll do means, in Hadoop what we'll do means, we will store this logs data into HDFS. We can analyze with the either MapReduce. If you don't have the knowledge about the Java or any other language, we can go with the Hive or Pig tools for analyzing the data. So, and finally we'll analyze the data. We need to show as a charts and graphs. For visualizing the data, we will have the different visualizing tools. Or if you are using the Java, any other programming language, we have the different frameworks for the visualizing the data. So we need to use that part. But most of the thing, visualization part, we won't take care. Mostly we will take care about the storing the data and analyzing the data. This is the one real-time example where we can use the in the Hadoop. Yes, Naren. So we can use the blogger.com or any other website. I given only examples of Flipkart and Amazon. Like that, we can any website, blogger sites or any WordPress sites or any other sites, any social media sites or any other sites. We will. This is the what we'll do backend. What we'll do with the Hadoop. We will do these kind of activities. We will do in the Hadoop. Next, we will other Hadoop use cases are the business point of view. Suppose if you are having the large amount of data, if you want to find the some insights. Insights mean useful information, and for improving the business and visualizing those different kinds of analyzed data, we'll use for the big data exploration. And if you want to enhance 360 different websites, analyzing the different kinds of business information, and also security point of view also. Suppose if we are in network log analysis also, we will use this kind of Hadoop thing. So if you have the any network, in network if you want to find the how much traffic we are getting from internally, and any of the devices is connecting to any malware websites, that kind of analysis also we can do in the security point of view, network analysis. And also fraud detection, or spam detection also we can do by using this Hadoop. Some of the use cases of the Hadoop. And also data warehouse modernization also. And nowadays most of the data warehousing systems, I think Informatica, some other tools also is integrating with this Hadoop. Most of the data warehousing is also integrating with the Hadoop. These are some use cases about the Hadoop where we will use the Hadoop. Coming to who uses Hadoop, basically initially Facebook and Yahoo, Twitter, most of the social media sites and searching engines only are using the Hadoop. Recent days, and lot of companies who are having the large amount of data, they started using this Hadoop technology. These are some initial companies who started using Hadoop. These are some details about who will use the Hadoop. Coming to vendor integration, recently lot of the other data warehousing tools or other visualization tools are started integrated with this big data. So some of the things are MicroStrategy, Talend, and Pentaho, Teradata. Teradata, I think it will become under data warehousing. So these are the things, vendor integration with the Hadoop. Some other things also there in Informatica, and some other technologies also integrated with the Hadoop. Next, in Hadoop we have the different distributions, Cloudera, Hortonworks. Basic distribution is Hadoop. Hadoop means this is the initial thing. So Hadoop we need to do everything manually. For avoiding that manual configuration and manual burden, we will use the Cloudera and Hortonworks. Next classes I will give more details about the Cloudera and Hortonworks. So these are the some popular distributions in the Hadoop, Cloudera and Hortonworks. Main thing is we will bundle the all the previously I explained some tools, Hive and Peak. So these tools basically we need to install manually. So for reducing the that burden, we can install as a bundle by using the Cloudera Hortonworks. But next classes I will give you more details about these distributions. Coming to prerequisite, what are the what are the technologies we need to needed for the learning Hadoop. Main thing is we need the basic Linux commands. So most of the Hadoop production environment we will install into Linux thing. So we need to having the basic knowledge about the Linux commands. Like I think if you are working previously, you are working with any data warehousing or any other technologies, I think maybe you will have the basic knowledge about this Linux basic command. Basic commands means how we can create the file folder, how we can see the file content, how we can see the files in the directory. That kind of basic commands only we need. I will provide the basic commands in the while starting the Hadoop. If you, I will give the basic commands, and I will give the this Linux environment also. I will give you. I will tell in next slides what are the things I will provide in the training. I will tell you. You need to having the knowledge about the basic commands, and also you need to having the core Java. Core Java we don't need about the J2E and other framework, Java framework like Spring. For the Hadoop we don't need those frameworks. So is it Java compulsory? Without knowing Java also we can handle tools like Hive, Pig. By using these tools, we can by using these tools, Hive and Pig, we can manage the we can analyze the data. So no need of without Java also we can manage, but some cases if we want to customize anything, we need the Java. But if you're having the Java knowledge, it will be advantage for the Hadoop. So without Java also we can learn the Hadoop concepts, basic concepts, Hadoop concepts, and we can work on the Hive and Pig tools in real time in company. If you want to work in Hadoop and without having Java knowledge also we can work. But if you are having the Java knowledge or any other programming knowledge, it will be advantage for the further in future. It will be advantage for the if you want to work with the any Hadoop Java integrated applications. If you want to work, it will be advantage. But suppose if you are working on ETL tools or if you are working on any data warehousing tool, that point of view I think you don't need about the Java. Just you no need to integrate that ETL tools or any other data warehousing tools or any visualization tools. Just you need to integrate with these Hadoop tools, and we need to get the data and we need to process. In that point of view, you don't need Java. But if you want to write any MapReduce programs, and if you want to customize anything in this Hadoop tool, that point of view you need the Java. For writing the MapReduce, we need the only Java. We can write with the other technology, other languages also we can write. We can write with the Python, Ruby, Perl, and C language. So we can write the MapReduce code with the other languages also. We in MapReduce we have the one concept called streaming. So by using streaming concept we can write MapReduce program in other languages. But basic language is the Java. Why means everything Hadoop is developed in Java. That's why only most of the developers will while learning will tell will write will most of the developers will write the MapReduce code in Java. If you want to write in other language, we can write. This is the basic idea about what are the needed. One more thing is SQL basics. We need to in Hive everything we will analyze the data with the SQL queries. So most of the Hive queries will be similar to SQL queries only. We need to having knowledge about the different select where and from class where class other basic knowledge about the SQL, how we can create the table query. But coming to Hive query language, this syntax and the concepts will be vary. I will, while if you are discussing about the Hive, I will tell more details about the Hive. These are the main things. So I think I have one question from Naresh. So for writing MapReduce concepts, we need to have the basic Java OOPS concepts, and the if you are having the knowledge about the some collection frameworks and exception handling, basic Java concepts. If you are having the knowledge, that is enough for the writing the MapReduce codes. And we have the different concepts like how collections also important for the Java, and also some concepts called generics also it is needed. That means we need the basic idea about the core Java, means OOPS concepts and the collection frameworks and the how this exception handling, that knowledge we need in core Java. Other than that, we don't need about the J2E concepts, Java, servlets, JSP. We don't need knowledge about those things. This is the basic idea what we need before starting into Hadoop. Next, coming to this thing, till now I am talking about the Hadoop and Hadoop ecosystem. Big data is Hadoop is equal to big data. No, big data. Hadoop is one main tool for the analyzing the data. Other than that, we have the different tools in the big data. One more component. Previously, while initially starting the class, I told NoSQL. What is NoSQL? So NoSQL also now getting familiarized. So NoSQL is nothing. Previously, before NoSQL, we have only one database. Only databases called traditional databases or relational databases. After that, now recently from 1 or 2 years, we are getting the NoSQL also getting popular. So NoSQL means not only structured query language. We can store the unstructured data, and we can store the data distributed fashion. And most of the NoSQL databases won't have schema. Schema means if you want to generally if you want to store any if you want to create any table in RDMS, we need to fix the schema. Schema means we need to fix the what are the columns we are having. We need to fix the schema. But in NoSQL, we don't need to fix the schema. It is the mostly schema-less databases. Most of the NoSQL databases are the schema-less databases. I will give more details in the next class. While explaining the NoSQL, I will give the what is the schema and what is the schema-less. Now what you need to understand means schema means we'll have the fixed columns. Suppose if you created the table with the fixed number of columns, you stored the suppose 10 million records. Now if you want to add the few more columns, that is the very difficulty to adding the more columns to existing tables or kind of thing. So in NoSQL, we don't need to while creating the table, we don't need to maintain the schema. So how we can without creating the schema, without fixing the columns, how we can store the data, I will tell in next class. This is basic idea about the NoSQL. NoSQL means not only structured query language. So till now Hadoop, what we'll do means Hadoop we will do analyze. We'll store we will bulk amount of data will store into HDFS and we'll analyze the data. But in NoSQL are the databases. These are the extents for the this RDMS. So what are the limitations at the database type? Okay, database side, what are the limitation means? We will use previously we will use only one database server for the storing all the applications data. We will have the uh, multiple web server type. We will use the multiple servers, and users side will lot of users will connected to application. But backend side in relation based in RDMS storage, we will have only one database. If it is failed means we will be lost the data. We won't have the distributed kind of storage in the database side. So if you are having if you want to store the large amount of data, if you want to, it will be more burden to the relation database, and also a lot of people are doing the reading and writing operations. It will be lot of load will be to the relation database. Coming to here, RDMS side, if you want to maintain the large amount of data, we need to pay lot of cost will be there for maintaining the large Oracle database kind of thing. So, and application performance also will decrease. More read and writes will be there. For a single machine will have a lot of burden, and it will be performance will be very low. This is the point of the web server. Till now, don't bother about this one. We need to take care about this one. Just you need to observe only this part, RDMS part. Next, coming to NoSQL thing. So what we will be in the NoSQL side? NoSQL side, we will provide the distributed storage. So data also, instead of storing suppose if we store any data in the database, instead of storing into one machine, it will provide the distributed data storage. It will provide in the NoSQL. So coming to here, suppose if a lot of users are interacting with the database, so we need to a lot of machines will be involved, and load will be less, and we can provide the large amount of data we can store. So basically in previous RDMS kind of thing, we can store only some amount of rows. So if you want to store billions of rows, it will be difficult in the RDMS. But it in the in NoSQL point of view, we can store billions of records and millions of columns also we can store into NoSQL databases. So if data is increases, we can decrease the cost. Why means NoSQL is also NoSQL database is also open source, and application performance also will be more performance also will be good, because multiple machines will be involved in the while reading and writing operations. That is the difference between the what are the RDMS side and the NoSQL side. Next, coming to the traditional database, what are the challenges we have? It is not good fit for the large data. Suppose large data volume, petabytes of data with different kinds of data types. Suppose if you want to store videos, images, or if you want to store the document files, Word files, Excel files, we can store into RDMS. So it is very difficult to maintain all the different kinds of databases in the data in the this RDMS. So for that, we have the different kinds of databases in the NoSQL database. Different kinds of categories are there. I will tell in the next slide. So we can scale for the large data volume. If we have 50 or 20 petabytes of data, we can scale. So other one of the good example is other project. Other project is using the NoSQL databases like HBase or MongoDB. They are using the these NoSQL databases. Other project for storing the finger thumbs information and some other information they are storing. They are using NoSQL database only for other project. That is one good example. And schema based means we will fix the columns while creating tables. Difficult for the adding more columns for existing table. I will tell more about the schema less in the next class. Scale up means, so if you want to increase the we can scale up means we can only increase the scale up to some extent. We can increase the RAM size or disk size up to some extent. After that, we can increase the particular single database we can increase. That is the one more limit for the this traditional database. Other thing is sorting. Sorting is nothing but a partitioning. It is possible, but the data node is failure means particular data is no data machine failure means data will be lost in the traditional databases. Sorting is nothing but a partitioning the tables. So, but all the partitions also will store into single machine. It won't be distributed into multiple machines. So, if one machine is failed means that partitions also will fail. That is the one more limiting traditional database. Consistency. So, consistency is also a limit in the this one traditional database. These are the limits in the traditional database. Then what are the why NoSQL? NoSQL is for the flexible schema. It will provide the schemaless databases, and distributed storage it will provide. It will provide the horizontal scalability. You can increase if you are getting more data. We can increase the number of machines. And non-relational. Most of the NoSQL databases are non-relation. If we don't have relation, how we can maintain the tables? That thing we will discuss in later. But I will give some examples, use case of the NoSQL I will give you, and it will also have the replication, and NoSQL is open source. Because of these features, most of the people are starting using the NoSQL databases. What are the different categories of databases? We have the four different kinds of databases: key value store, column-oriented database, and document-oriented database, and graph-oriented databases. These are the different kinds of databases. I will give introduction about these databases in the next classes. These are the different kinds of databases. So I think mostly in training I will give the basic introduction about the different databases. What are the different kinds of databases, and I will tell only HBase. HBase is the one of the NoSQL database in the Hadoop. So I will discuss only HBase. In training also I will give more details in the HBase. Remaining databases, what are the different kinds of database, I will give just information. But only HBase only I will in training session I will give training on the HBase only. We have the different kinds of databases, key value, and graph-oriented database is Neo4, this is popular. Column-oriented database is Cassandra and HBase. Document-oriented database is MongoDB. So, what are these different kinds of databases? I will give more details in the next classes. You can also start reading some articles on the NoSQL databases. You will get some idea about what are the NoSQL databases. So in interview point of view, if you are having knowledge about any database, it will be good. Either it will be HBase or it will be Cassandra or MongoDB. It will be good in the interview point of view. And most of the companies have started using these HBase, Cassandra, and MongoDB, and Neo4 databases. These are the basic introduction about the NoSQL databases, and where we'll use the NoSQL database. I told we don't need to provide the relations. Without relation, how we can maintain? So these applications, these chart messages or user notifications, graphs, we don't need to maintain the relations in Facebook chat messages and user notifications. So in these are the use cases of the NoSQL. So if you coming to Facebook are using the HBase. HBase are using for the Facebook messages and Facebook chats. I think most of the people, if you want to in Facebook, if you want to chat with other friends, you will get one dialog box in the bottom right corner. So that Facebook, the chat messages are internally using the HBase database, and also emails and Facebook SMS messages also we are using this NoSQL databases. Mostly for these Facebook are using HBase. And also notifications, we will get the notifications if any people are likes any images or any video or any post or any comments, we will get the notifications. Those notifications also will store into this NoSQL databases. Why means, suppose if you take the messages, means daily we are generating the lot of people will generate the lot of messages, lot of data. So that data we can handle with the RDMS, and these notifications also we can handle with the RDMS. So for this only, for these different kinds of applications, we are using the NoSQL databases. NoSQL databases, we can do any analysis with the NoSQL database. Only if you want to analyze the data, we can use the Hadoop ecosystem tools. If you want to store these kind of, if you are having these kind of applications or these kind of use cases, we will use the this NoSQL database. And notifications in the Flipkart notifications also, they will use NoSQL databases. And graph search, I think if you observe Facebook top side, we'll have some graph. For this they are using some graph databases. For if you want to know about the friends of friends, or friends of the who are working in some company or some college, who are they working, if you want to know those details, we'll use this graph search. Internally, graph search will use the graph databases. Graph database mainly related to connected data. These are the basic idea about the NoSQL. Next, coming to what are the other than this Hadoop and NoSQL, we have a lot of other tools. But now in market, if you are get into company, or if you want to start with Hadoop, we need to know about the Hadoop ecosystem tools, basic tools, HDFS, MapReduce, Hadoop, and also NoSQL databases called any database, HBase or Cassandra or MongoDB. We need to learn. In NoSQL point of view, only HBase only under Hadoop ecosystem or Hadoop family, only HBase will come under Hadoop. Other NoSQL databases will use some other internal storage or some other things. It will use all the NoSQL databases. But in Hadoop, we have only one NoSQL database called HBase. Next, these are the other technologies we will use in big data technologies. NoSQL, other database, Cassandra, MongoDB, CouchDB, DynamicDB, and also Kafka and other. From searching side, we have the different Elasticsearch, Solar, and also visualizing or statistic analysis side, we have the RI. 1 minute, I have one question from Nare. What are the other popular tools for big data other than Hadoop? What is the current Hadoop? Big data tools means if you want to analyze the data, main tool is the Hadoop. Other than if you want to store the large amount of data, if you want to pass data, Hadoop is the, till now, big data, most of the 90% of the people is using the Hadoop. These are the other tools based on the related to Hadoop, or other tools or other tools they are using for the different purpose. The Storm or Spark, these are the different applications we will use for this. If you want to do any processing or analyzing, they will use other tools. But till now, Hadoop having a lot of market in the Hadoop. These are the other tools, Storm or Spark, other tools. This is the what is big data and what is Hadoop, what is NoSQL, and what are the other these Spark and Storm and other technologies. If you are starting learning with the Hadoop, then we will get the more details about the we can get the idea about these other tools, Storm and Spark. Initially, if you want to start with big data, present market Hadoop is the we need to learn the Hadoop ecosystem tools, and we need to learn any one of the NoSQL databases. These are the basic what is Hadoop and what is big data and what is NoSQL and what are the other technologies in the big data. So other technologies also different companies are creating the different tools for the their purpose, for their uses. So Storm is created by the, I think, Twitter, I think LinkedIn created some tools, Twitter created some tools, and Facebook created some tools like HBase or Cassandra. So this kind of tools are created by the most of the popular popular companies only creating, and they are including into Apache family. Those are the basic idea about those things. In training period, coming to time, I think most of the people, I think you understood about the what is the big data terms and what is Hadoop and what is NoSQL. I hope everyone is understood. If you understood, please give yes. Okay. Thank you. Thank you for the replies. Okay. In training, I will give the Hadoop materials and VMware software, and basically how we will start the Hadoop means. Initially, I will tell the what are the theoretical concept. Then I will install the. Then I will how we can install the single node and multi-node cluster. How we can practice. I will show in my laptop by using the VMware. VMware, we can create the single laptop. We can create the multiple nodes. We can I will start with single node, then I will create 2-node cluster and 3-node cluster. Then I will show how we can do the how we can replicate the data. What are the concepts we are talking about theoretically? I will explain. I will show practically, and for you also I will provide the all the software. I already uploaded into Google Drive. I will give the once we started classes, I will give the Google Drives. You can install and you can practice, and also I will provide the materials for the this Hadoop thing, and also I will give the Hadoop hands-on commands and examples, and I will also give some standard books. What are the books are needed for learning the after this training, and Hadoop distributions also I will tell. I will tell about the Cloudera distribution and Automotive distribution. These are the I will provide in the these things. So most of the materials and the other VMware tools, actually VM workstation tool and documents, and also I will give the some softwares for if you want to install the Linux and if you want to install the Hadoop. Everything I install in the one VM instance, and I will give that VM instance. That VM instance will be nearly 3 GB of data. So you need to install and you need to download. Once you download, I will tell how to install and how to use the Hadoop tools. I will tell you, and I will give the what are the tools, what are the softwares we needed. I will give you, and also I will provide the basic Hadoop books, and I will give some Hadoop practice code for the different tools. I will tell what are the commands and what are the examples. I will also give. I think most of the people, I think you got the training material. I think Hadoop Tyler. I think I sent to some of the people. If you want, I will send. Please share, all of you. Please share the mail IDs. I will send this. What are the topics or what are the tools and what are the topics I will cover. I will give details, more details. So in training, I will cover all the HDFS, MapReduce. These are the concepts I will cover. Hive, Pig, Scoop, Flume, NoSQL. I will give the introduction about the NoSQL, and HBase. I will tell about the HBase, and also I will give the weblog analysis, and I will give the 2 POCs, how we can analyze the weblogs, and also I will give the how we can analyze the Twitter data. Those POCs I will explain, and also I will give the introduction about what is Cloudera and how the Cloudera distribution will be there. I will show. These are the topics I will discuss in the this Hadoop training. Based on your response, I will decide the training timings. Mostly, I will please send all of you send the mail IDs. Then I will discuss. We will discuss, or you can contact with me. I can provide the training timings. Once again, thank you all for the attending the demo. If you have any further discussions, or if you want any further details, you can contact me at this mail ID and the phone number. Thank you. Anyone having any questions right now?
No, Srinu, everything is good.
Okay, okay. Thank you. Okay,
Thanks.
if
We'll
anyone
talk
want
to
to further details, you can contact me. You can contact me.
okay.
Okay,
Okay.
thank you. That's all for the today demo.